Hi, welcome to this new tutorial. We will learn how to rig and animate this machine. Let's begin by rig the piston and piston rod. Select the piston rod, and the crankshaft. Isolate them by press the slash button. Go in orthographic view. Select the crankshaft and snap the cursor to his origin by using Shift S. Select the piston rod and Shift S to snap cursor on his origin. Select the bone and go to Object, Transform, and Align Objects. Choose Relative to Cursor and Align to Y. We need to activate the in-front view to work easily. In Edit mode, snap the bone tip on the cursor. Select the bone and switch his direction. Select the piston rod and go to face mode. Switch to wireframe mode and select those faces. Just use Press Alt or Option on Mac, then select one face to select the ring. Shift S and cursor to select. Let's back in solid mode and switch to orthographic view. In edit mode, select the bone head and extrude in Z-axis, then snap on the cursor. Alt F to switch direction. Do the same for the two next bones. I use Control button to snap on the top of piston. This one will be the stretch bone. Let's check in pose mode. This one is free, those two. Let's connect them. Now select this bone and make it child of the top one by connect. Okay, great. Now let's get more room here. A little bit. Select the free bone, shift select the bone on top, the press shifting to add icon. Okay, good. Change the transform pivot point to cursor and snap cursor to select. Let's see in pose mode. Change the orthographic view. The movement is coming now. We need to activate stretching on the top bone. Okay, good. Now we need to constrain the movement on the Z-axis. For that, select the stretch bone and go to Ec tab and lock Z-axis. If we activate axis of armature, we can see local bone axes. So let's lock the Z-axis. What's going on? Sorry, I lock X-axis instead of Z-axis. Let's fix it. Okay, great. Okay, now let parent objects to bones. In pose mode, select the piston rod bone and back to object mode. Select the piston rod, follow armature, and Control P to parent as bone. Do the same to parent piston. Let test it. I think it's worked well. Back to the original scene and see how it worked. We need to duplicate the control bone and use the copy to force it to rotate around the tip. Switch direction of the copy and parent them with keep offset. Parent the new bone with crankshaft to complete the rig. Okay, not bad. Let's change quaternion to Euler rotation. Now you can try to rig the other side for training. I'll show you another way by duplicate some bone. Let isolate those pieces. Select the piston rod B and snap cursor on it. In edit mode, select the four bones. Change the transform pivot to active element. Then go to armature, snap selection to cursor with keep offset. Let duplicate before. Okay, great. Clear parent of last one. The IK constraint is not tired. Switch direction and snap on cursor to match the first configuration. It can't work yet. We need to change the rotation axis. In edit mode, duplicate it like before and switch direction. Add parentage with keep offset. Now it worked well. Maybe we must increase the size of the stretch bone. Let's do it like that. It's better now. Just create bone parentage to end rig. Excellent. Parent the new bone to control bone with keep offset. Okay, cool. Let's test it one last time. Let's rename this bone control bone. Everything seemed good. Now we will create a custom circle for the control bone. Shift A and create a mesh circle. Just scale it a little bit. We can use a value of 2.2. In viewport display, choose the circle as custom object. Let's create a casual animation. Add a single keyframe on Z rotation at frame 1. Then put the cursor at frame 30 and key Z rotation with a value of 180. Right-click on timeline and choose linear interpolation. Let's animate gears and pulley. Be sure the right axe rotation is Y and lock other axes. We will use drivers this time. Copy the Z rotation of controller as new driver. Paste to rotation of this gear. This attribute is Z rotation of controller. If we play the animation, the gear rotate in the opposite direction. Edit driver with script expression and put the opposite value by use the minus sign. Okay, great. We'll use the Y rotation of the first gear to control the Y rotation of the small gear, and it must rotate 2 times faster than the first one. So copy the Y rotation as new driver and paste a small one. Let's apply the scale and rotation. Pass driver and edit driver. Change to script expression and put the opposite. The value of his velocity is 2 multiplied by velocity of the first one. So edit driver and multiply by 2. Okay, correct. Next, let's animate the big one. The big gear must rotate 4 times less than the small one. Copy the attribute as new driver and paste it. Maybe copy as new driver. Paste driver and edit. Use the reciprocal and divide by 4. It's look good. Now copy as new driver for the pulley A. I lock the unused axes. You can pause video and try to do the same with pulley B. We can uncheck in front and axes for the armature. Let's animate valve cam and push rod. Just proceed like before. Let's isolate valve cam B and push rod B. We'll animate the push rod in the action editor. At frame 1, insert a single key on Z location. Scrub the timeline until the valve cam is high. Raise the push rod and keyframe. Adjust as you like by move the second key. When you are satisfied, put the last key after 2 frames. We can adjust animation in Graph Editor. We can move the tangent handle to adjust the easy in and easy out. Okay, back on Action Editor. Create a fake user and unlink data. We'll use Action Editor to start pushrod animation. Chose Z rotation controller as target in local space. I'm looking for good limit for animation. We'll try this value and adjust if necessarily. Sorry, it's Z rotation. Let's adjust the max value. It's not bad. Try to animate the second pushrod. Another way is to copy constraints. Select the pushrod A followed by pushrod B and copy constraint. The pushrod B most begin after 1 revolution. I'll use an empty to set it. We just subtract pi radian to begin at 0 after 1 tour. Okay, great. In the Action Editor, set the target to empty Y rotation. Change the Z rotation to Y rotation world space. Okay, good. Let's animate the beams and springs. We can hide armature for a while. Push rod should move up the beam. Like that. Just add an empty on top of the push rod. Align the empty with beam origin in Z-axis. It's very important to do it. Parent the empty to push rod. Another important trick is to align the track axis of object and target. The two origins are aligned in x-axis. Add a damp track with x-axis track. For the spring, we'll use a constraint action. Let animate spring before, like we do with push rod. We just need 3 keyframes at the right place. Adjust as far as you can. Copy the constraint of the push rod and change target channel. Just use the spring action. Unlink action before. The end frame is 11. We'll now copy the constraint for the spring A. Add an empty on push rod A to drive the beam A. Align track axis and copy damped track constraint. You can use top view for easy work. You can copy the X rotation of the beam and paste to X rotation of empty. Don't forget to change the controller by the empty in order to begin after one revolution. It seems run well. It's time to rig the belt. I already have a belt piece. We'll duplicate it and align on the curve. So look at Array Modifier and set Fit Type to Curve. Select the curve and I'll use Constant Offset. Change the distance X until fill gaps. Add a curve modifier and choose our curve. By change the X location on the belt, rotate. It's ready to be animate. For this, I need the radius of the pulley A. It's about 0.27. Copy the Y rotation as new driver. X location equal radian rotation times radius. To get the rotation of pulley B, just divide the X location by his radius. So copy the X location of belt as new driver and paste to Y rotation of pulley B. Then divide the attribute by the radius. I'm sure you can create and animate the conveyor belt. Thanks for watching and see you next time. In the second part, we will animate the robot arm. Don't forget to like and press the bell so you don't miss any of the next videos.